Hello, just after learning how to convert a binary number to a decimal number, we now want to learn how to convert a decimal number back to a binary number. Converting a decimal number to a binary number. A binary number in order to convert a decimal number to its binary equivalent, we can use the remainder method. And this method can be used to convert a decimal number into any other base. And the steps that are involved in the remainder method are as follows. Steps, remainder method. These are the steps. 1. Divide the decimal number by the base. In the case of binary, we divide by 2. So in the case of binary, divide by 2. Then step number 2, indicate the remainder to the right. Indicate the remainder to the right. Then the third step, continue dividing into each quotient and indicating the remainder until the divide operation produces a zero quotient. Don't worry, we shall do it practically here by an example. Then you'll see produces a zero quotient. Then the last step, the base 2 number is the numerical remainder. Reading from the last division to the first. For example, if you start at the bottom, the answer will read from top to bottom. The answer will read from top to bottom. As in, if you start dividing from at the bottom, as you go to the move to the top, the answer will read from top to bottom. And if you start dividing from the top the bottom, the answer will read from bottom to the top, as simple as that. Let's do some examples here and then you see. For example, if you ask to convert, for example, if you ask to convert a number like 99, a decimal number 99 base 10 to its binary equivalent, So for me, I want to start from dividing from the top to bottom, so that my answer will read from bottom to the top. So it's 99, we divide by 2 since we are converting it to the binary, so we shall divide by 2. Now binary is 2, so 99 divided by 2 is 48. Remainder is 48.5, but now we are dealing with the whole numbers here. One is either 1 or 0, so it's 48 remaining 1. 48, not 48 but 49, sorry, 49 times 2 is 98. We remain with 1. We write here, so you can see the following the steps. Divide the decimal number the base, indicating, and then I'm indicating the remainder to the right. Now I have indicated here 1. Another one, 49 divided by 2 is 24. 24 times 2 is 48. We remain with 1. Have also indicated. I continue indicating the remainder and indicating the remainder until the divide operation produces 0 quotient. So I continue. 24 divided by 2 is 12. 12 times 2 is 24, so the remainder is 0. I have indicated to the right out there. Then 12 divided by 2, 12 divided by 2 is 6. 6 times 2 is 12, so the remainder is 0. 6 divided by 2 is 3. 3 times 2 is 6, so the remainder is 0 still. Then 3 by 2, so it will be 3 by 2 is 1. 1 times 2 is 2, the remainder is 1. Are we there? So I have been told that you have to continue dividing until the divide operation produces a 0 quotient, produces a 0 quotient. So still then you have 1 divided by 2 is 0 out there. 0 times 2 is 0, the remainder 1. So since I have started my divide operation from top to bottom, I will read my answer from bottom to the top. So my binary equivalent will be 1 1 1 1 is 1 1 0 0 0 0 0 0, then 1 1 1 1, and that is the answer. We can do another example. For example, if we're given like 13, for example, we're given like 13, 10 to its, we ask to convert this to its binary equivalent. Again, I start from top to bottom. Remember, it's your choice. You can start from bottom to the top, but for me, I have preferred top to the bottom. There's no problem. So it's 13 divided by 2 still. because we want to convert to binary number. It is 6 times this is 12, 13, remainder is 1. Are we there? We have indicated the right. That's rule number 2. Rule number 2 there, indicating. We continue. 6, 2, it is 3, get 6. 3 times 2 is 6. We remain with 0. Are we there? Then 3. So 3 divided by 2, 1. The remainder 1. Again 1, 2. It is 0. The remainder 1. So since I have started from the top, dividing from the top to the bottom, I read my answer from bottom to the top, so that I get 1, 1, 1, 1, 0, 1, 1, 1, 1, 1, 0, 1, 2. There's 2.